Hi guys, welcome back to the channel. Hope you all are doing well. Today we're going to build a notification system that you see over here. This is how the final design is going to look like. We're going to build the whole thing from scratch. At first we're going to start with something basic and get a working version out there at first. Then we're going to talk about the different problems with that system. And gradually we're going to add things on top of the system to finally come to the version that you see over here. So to get things started, at first, let's talk about what are notifications in a notification system. So notifications can take many different types in a notification system. Usually when people think about notifications, they only think about push notifications. However, notifications can also be email or SMS. So essentially any kind of message that you're sending to the user to notify them about something is a notifications. So some examples that I included over here are, let's say that a user got a new message and you want to tell them about them. That's the perfect use for a push notification. Let's say you have an e-commerce app and your user is interested in a product that just got a new discount. You want to tell your user about it, so you can send them an email notification telling them about it. Similarly, let's think you have sort of like a maps application and a new restaurant opened up near one of your user and you want to tell them about it. You can just shoot them an SMS or maybe an email or a push notification for that. So these are some of the more real-life use cases of notifications. So now that we know what exactly are notifications, let's start building the system from scratch. So I'm gonna move this to the left so that I can gradually build things on top of it. And then, okay, so this is where we're gonna build the system. I have the individual components over here, but we're gonna put all of them together gradually and talk about them as we go along. So the first thing we need is the system that is going to be responsible for actually sending these notifications out. So we're going to use a microservice or a service for sending these notifications. The only job of this service is going to be getting all the information it needs to send the notification and then actually go ahead and send the notification. You can either think of this as a standalone microservice or maybe even sort of a Lambda function or something more temporary. But the main goal is this service or system should encapsulate all the information you need to actually send a notification to a user. So now that you have a system or a service that's actually going to send the notification, you might be wondering what's actually going to trigger these notifications and how. So for triggering the notification, we can do it in multiple different ways. We can have other microservices. I'm gonna increase the font here. Yeah. So we can have other microservices that can call the notification microservice to send the notifications out. Right? So something like this. I am gonna increase this. Okay, much better. Let me increase this a bit more. Perfect. Okay. So we can have other microservices that are calling the notification microservice to send the notifications out. We can also have scripts, just one-time scripts that you write. The scripts are gonna iterate through all the users and then hit the notifications microservice to send the notifications out for the users. So we're gonna put that, and we can also have cron jobs. These are like one-time sort of like batch processes that can be scheduled so that, let's say, every morning at 9 a.m. the cron job is gonna run and call the notification microservice to actually send the notifications out to a bunch of users. Right. So now the question is that we have all these upstream services which can call onto the notification service. But how do they exactly call the notification service, right? And that can be very simple. We can just have a post endpoint. I am gonna, where is it? Bear with me. So we can just add a text here. Perfect. Yeah. So we can have a post endpoint to this, maybe like something like this. Yep. So we can have like a post endpoint called send notification, and all the upstream services like the microservice, scripts, or cron jobs can just make a HTTP call to this endpoint, which is gonna actually call the notification service. All right, so we have something in place now that is gonna trigger the notification, which are these jobs you see to the left. And then we have the notification microservice that's actually gonna send the notifications out. So of course the question is, how does the notification microservice send these notifications out? And for that, we're gonna use a bunch of third-party applications that are out there for any kind of notifications. So the first one is gonna be, let's say, an email service. Right? So there are a bunch of email services in the marketplace. You can have things like MailChimp or Braze, or even AWS has an email service. So you can use any of these services to just send the email out to a user. We also have SMS services like Twilio. These are services that you can interact using an API. You give it a phone number and a message, and Twilio is gonna send the SMS for you. Okay, there we go. Let's not have this. Okay. And finally, for the push notifications, you can use the default iOS and Android libraries to actually send these push notifications out. So these are going to be the standard SDK that Apple and Google provides you to send the SMS out. To send the push notification out. So all these are going to be third party. So we're going to be pretty much interacting with them through APIs or some other kind of communication, but we won't really own any of this. Maybe we will own some part of the push notification, but still you're using the operating system's SDK to actually send these out. All right, so now we know that we have upstream, we have scripts, microservices, and cron jobs that are calling the notification microservice through an HTTP request. The notification microservice is going to use these third-party libraries or packages to actually send the notification to the user. And here we can have the user for visualization. So the user can get email notification, SMS notification, or just push notification. Okay. All right, so now that we have this system in place, of course, the notification service will need some information about the users that they're sending the notifications to, such as their email, their name, and other stuff. So for that, we're just going to use a simple MySQL database, right? So let's just, for now, let's just have the user information. Okay. And then this is going to talk to the database. All right, perfect. There you go. All right, so now we have a working version of the notification system where upstream there are multiple microservices, scripts, and cron jobs that are using the HTTP post endpoint to call the notification microservice. The notification microservice, when it gets a request for a notification, it's going to talk to the MySQL table with all the user information, get the relevant information, and then use one of the third-party notification service like an email service, an SMS service, or a push notification service to actually send these out to users. One thing that you can take a look at is the user table that we were talking about. So this one. And it's going to be pretty bare bones. We'll just have a simple MySQL or Postgres table with user ID, opt-in status, because you have to know whether the user is opted in to receiving communication. Their email, of course, it's going to be encrypted, and you want to make sure like they are kind of denormalized or normalized, whichever you call it, so that the user ID and the email cannot be like properly connected together. And then you have the device ID, which you might need to send the push notifications out. All right, so now that we have this working version of this, now let's talk about some of the problems that this simple system might have before we start adding more things on top of it. Okay, so the first problem is that in this system, you have a single point of failure. So you have this one notification microservice, which is the single point of failure. If for some reason this service is down, every single request that your upstream services are making to the microservice are gonna fail, and those notifications are just gonna be lost. Of course, when it comes to notifications, you don't want them to get lost, so this is a pretty bad problem for of this system. Also, you can have the server being overloaded, like the notification microservice, given it's a single point of failure. Let's say if you have a cron job that is running every morning at 8 a.m. and calling this microservice with all the users every single morning, it might be very easy for the microservice to get overloaded, even if you're doing like a horizontal scaling. This way, you still have the chance or the likelihood of the whole microservice failing. That's going to lead us to notifications lost. So whether the service is down or did not scale fast enough, as long as the service is returning error messages to your upstream jobs, those notifications are going to be lost because we're not retaining the notification anywhere. And finally, we already talked about it. It's difficult to scale because here we are talking about scaling one entire microservice every single time there's a spike in notifications. It's not trivial to spin up one whole service with a lot of other infra-related things. It's easier to scale individual workers or individual functions like Lambda functions, but it's more resource intensive to scale one whole microservice every single time. All right, so these are some of the problems associated with the system we built. So now let's start addressing them, okay? So of course, the first problem over here, and I would say the biggest problem, is the notifications that are being lost. And we wanna somehow retain these notifications so that even if the microservice is busy, it does know how to retain them for future processing. So for that, we are gonna go ahead and remove these for now, and we're gonna talk about the changes. Let's move them. Okay. So to reduce the work on the notification microservice, we are gonna add in a message queue after that, okay? So we are gonna have a message queue, and then let's join them. And I am gonna increase the font. Okay. Okay, just bear with me. There we go. Okay. So the question is, how does the message queue help over here? And it's pretty straightforward. What the notification microservice is going to do now is the moment it gets a request from any of the upstream system, it's going to get all the information from the MySQL table, which should be pretty quick, and then add that notification to a message queue. This way, the notification microservice does not have to deal with the complexity of calling all the other third-party systems, which is where the most of the time-consuming things happen. So all that the microservice is going to do is get a request, pull the information required, and then add that message, create a message and add it to the message queue. And this way, no matter which one you use, Kafka, RabbitMQ, or some other messaging queue, they should give you the ability to retain messages for a period of time. So even if your notification microservice is writing to this message queue very, very quickly, you can still retain the messages as whatever is gonna consume from the queue can scale up and down according to the traffic. So message queue gives us two benefits over here. Number one is it gives you a place to retain these notifications before they're being sent out. And it kind of makes the job of the notification microservice easier, because now this is not what is responsible for actually sending them out. The only job the microservice has is to receive a notification request, form the payload, and write a message to the message queue, which is significantly less work than going ahead and sending all of these out and dealing with all the other complexities. Okay, so now of course, the typical question is, now that we have all these notifications in the message queue, how do we actually send them to the user? And for that, we're going to use a bunch of workers. So we can have like 3 workers. There you go. So these workers are going to be very lightweight functions or Lambda functions or just processes that are very easy to scale. So these are going to be literally like a function or something very straightforward that has only one job, that is to consume a message from the message queue and send it to the end user. So they don't do anything else. They don't support a bunch of HTTP endpoints or anything like that. These are simple Lambda functions or just Python or some other language functions. All they do is they read from the message queue and then go ahead and send the notifications out. So, okay, so they are reading from the notification. So a big benefit, let's actually just have 2 workers to make things simple. Yeah, a big benefit of this is these workers tend to be very lightweight. So they are very easy to scale up and down depending on how many messages are being stored in the message queue. Instead of scaling this whole microservice every single time you have a spike in traffic, now you can just independently scale up these lightweight workers, which is significantly easier and much less resource intensive. And given the message queue is already giving you temporary storage to store these notifications, you have the buffer to go ahead and scale these independently, depending on the size of the message queue. So the workers are gonna read from the message queue, get all the data, and then use these third-party APIs to actually send them out. Okay. Now, we have a much more scalable version of the system that we built at first, but we still have a problem, which is what happens if when these workers are trying to send out these notifications, what happens if the APIs that they're using over here, they fail or error out for some reason? You might still lose that, right? Because right now, the worker is going to read the message from the message queue, and the message is going to be gone from the message queue. They're going to try to process the message, it fails, and now the message is going to be lost, which of course is not something that you want. For that, we can have a new table. Let me see. Yeah, we can have another table, and this is also going to be a very simple MySQL or any other relational table, which is going to store every single notification that is being sent out. So this is just an example schema of the table. We can have a notification ID to make sure every notification is sent only once. You have status, which is going to be status it can be delivered, pending, so in a waiting stage, or failed. You have retry count, which is the number of times you tried retrying. So you can have logic such as, if you tried sending this notification 5 times and still you did not, then just forget about it because there might be something wrong with the payload. The device ID, the notification is being sent to, the user ID, and the timestamp. So very simple relational table. Let's add that over here. So we have the user information, and we are also going to have the notification info. Okay. So the first thing that's going to happen is when the microservice is actually writing a message to the queue, it's also going to write a row to the MySQL table, giving it maybe the pending status, right? This means that the worker is yet to process it. Every single time the worker is done processing a message or a notification, it can write back to that table. This way, whether it's, let me just add tag. Not them here. Yeah, so success or failed messages. So whether it's a success or a fail, it can go ahead and update the MySQL table. So the table we're talking about is here. So if it delivered it, it can just change the status to delivered. If it failed, it can go ahead and change the status to failed. So now we have our relational table, which is persistent, and it stores all the information about every single notification independently. You can make an argument for having a non-relational table here, because of course, when you're talking about MySQL, when you're talking about notifications, they tend to be very high volume, and writing very, very fast to a MySQL table can be not very performant because of replication lag and other issues. So you can make an argument to have a more write-intensive table, like a Cassandra table or something, but in our case, given the scale we are talking about, we're gonna keep it to a MySQL table. But you should know that if you know for sure that your notifications are gonna be very high volume, you can consider using a Cassandra table instead of a MySQL table to store the notification information. Okay, so now we have the workers processing them. If the workers fail while processing them, we still have our notification table that has the information about notifications that are being failed to send, that are failing to be sent, right? So I'm gonna pull this down, and then this goes over here. Actually, just give me 1 second. Let me organize this better. Okay, so we can have something. Okay. So now that we have failed notifications in this table, of course, we need a way to pull these failed notifications and send them back to the message queue so that they can be processed again. Because when the worker is reading from the message queue, the message that it just read is deleted from the message queue. Now, when the worker is failing to send this notification out, of course, they're updating the state of that notification in this table. But that notification is lost from the message queue. So that's where a scheduled job comes in. So you can have a batch or a simple cron job that runs regularly. So let's say once every hour or once every 30 minutes. What it's gonna do is pull all the rows from the MySQL table, so the notification table that has the status set to failed. So these are the failed notifications, and it's gonna re-enqueue them in the message queue. Okay, so all this is doing is reading the failed notification from the MySQL table and re-enqueuing them in the message queue so that the workers can attempt to send it again. If it fails for the second time, the worker is going to update the status of that notification to failed again, and the notification scheduled job is going to pick up that failed message again and then re-enqueue it for further processing. You can have an upper bound. So of course you see over here, we have a retry count. So you can tell this job that if a row has been, or a notification has been retried 4 or 5 times, forget about it. You don't have to enqueue it again. So you can have logic like that to make it more, to make it less busy. Yeah, so I think that pretty much sums up everything I wanted to talk about. So now you have a pretty decoupled and scalable notification system. I'm gonna run you through the whole thing one last time so that you get the full picture. We have our notification microservice, which is the main interface that all the upstream services have to interact with when they are sending a notification. When it comes to the upstream services that are gonna trigger these notifications, they can be other microservices, standalone scripts, or cron jobs. All they do when they want to send a notification is call the post endpoint with some payload. Now, once that endpoint is being called, the notification microservice is going to receive that HTTP call. It's going to talk to the user information and the notification info table to get all the information required, form a payload, and write a message to this message queue where the notification is gonna stay temporarily. And the microservice can also write a row into the MySQL table with the notification ID. Now you have all these messages being written to the message queue, and you have these workers that are subscribed to a topic in the message queue, and it's reading from the message queue to actually send these notifications out. These workers are going to be very lightweight, so they're going to be very, very easy to scale. In the case where your message queue is growing indefinitely and very, very quickly, you can scale up these workers to consume much quicker. The workers are going to consume notification messages from the queue and then send them to the user through these third-party APIs like an email service, an SMS service, or a push notification. While sending these out, if the workers run into any errors, they are going to update the status of that notification in the MySQL table. To give you an example, if we have a table like this, the worker can just go ahead and with the notification ID, update the status of this notification to failed. You're gonna have a scheduled job that is gonna run once an hour or once every 30 minutes. That's gonna pull all the failed notifications from the MySQL table and re-enqueue them into the message queue so that the workers can attempt to send it again. If for any notification you tried up to X amount of time, so let's say 3 times in this case, you can tell your failed notification scheduled job to not re-enqueue that message, because odds are if you failed to send it 3 times already, it's not worth trying to send it again. So yeah, I think that covers pretty much everything that I wanted to go through. Hopefully this was helpful. If you want, feel free to take a screenshot of the system if that's what helps you. Yeah, so with that being said, hopefully this was helpful. The next system design we're gonna work on is, I think, related to a newsfeed, like an Instagram newsfeed or a Facebook newsfeed. That's also gonna be pretty interesting and are gonna have some use cases or unique cases that this system had. So I would recommend subscribing to be notified whenever that video goes out. With that being said, I hope you guys have a good rest of the day, and I'm gonna catch you guys in the next one. Bye bye.